do this. Okay, so let's get this party started. All right, so yesterday we started an activity where we had you guys counting protons, neutrons, electrons of little atoms that you guys were looking at. We are going to finish that today after we talk about what's on your quiz on Friday. Today is Wednesday. This is the practice day. Thursday is a lab for you guys in class. And then Friday, we will always have a quiz. So the quiz is written. The quiz is 5 questions. I know that looks tiny, but I'll explain myself in a second. And it is 29 points. Everything on the notes from Monday is fair game. So that whole first 2 pages of your packet, make sure you're comfortable with all that information. There is going to also be a Petri dish on that quiz. Well, you'll have to count protons, neutrons, electrons, and you'll have to be able to fill in a chart just like what we're doing over these last 2 days. So I wanted to make it pertinent to what we're doing. So you want to make sure you're working on the activity here because you'll have an example of that. And then there are going to be 2 questions that look just like Bellwork number 2. So if you can flip past the activity we did yesterday to where it says atomic structure Bellwork number 2, I have put basically it looks kind of like this, and I'm not guaranteeing you that the headings are the same because the problem is if I leave all this the same, people just memorize like column 1 and column 2, subtract from column 4. So we're not doing that. So you have to actually know what's happening. So the top might be different, but one of the questions looks like this. It has 16 answers on it. So that's how you're getting a lot of points, okay? There is also a question that looks like the back. So let's go through these today and make sure that everybody knows how to do this so we're ready for our quiz on Friday. So take a look. Atomic structure Bellwork number 2. Everybody's got to it. All right, get out the periodic table. Got it. Let's do it. Number 1, I see that we have selenium. You can find selenium on your periodic table. It's an SE. It's kind of more on the right-hand side over here. How many protons in selenium? You look at the number at top. Very good. Okay. So the atomic number is 34. If you want to get yourself a little information, we can circle. The atomic number always tells me the number of protons. So that means I also have 34 protons. All right. Now, you've been given a mass number. So that means you need to be careful, and you don't always use the mass off the periodic table. If you've been given a mass number, use what you've been given. Or if you've been given neutrons, use what you've been given. Okay. So I have a mass. Mass number, remember, was A. Atomic number was Z. What do I do with A and Z to figure out number of neutrons? A, good job, minus Z. So in your calculator, you can do 79 minus 34. Boop. It's going to give you, very good, 45 neutrons, right? Because the only things that have mass are protons and neutrons. Awesome. Now, and if I got one question yesterday, it was all about charge. People are like, okay, I got that, but talk to me about charge. The 2 things that have charge, you can make a little note on your periodic or on your thing here. Protons are positive and electrons are negative. So if you're trying to find electrons, you need to look at the charge. If you're trying to find charge, you need to look at protons and electrons. If I have plus 34 minus 36, which one do I have more of, pluses or minuses? I got more minuses by how many? 2. Perfect. So you're going to be a -2. Oops, wrong thing. -2 charge. Okay. Awesome. So you will have to be able to fill in a chart like this on your quiz. I'm also going to do one example on the back for you, and there are more of these practices on the back of your packet that you're going to finish today. So I know there's only 2 up here, and I'm going to do one of them. You can guarantee you're going to see a question like this on the quiz as well, too. Talk to me.
So if you have more protons, it'll be a
positive 2. If it's more electrons, it's a negative 2, okay? And so here, let's just do one more here because sometimes it is a little confusing. Let's say, you have 28. We know we have 28 here. If I want to end up a positive 2, and I know I have 28 protons, that means I have to have 2 less electrons. So how many electrons would I have here? You got it, okay? So that's kind of how you figure out charge and electrons. You're always looking at protons and electrons, okay? Awesome. On the back, the trickiest part of this question here is it says, please keep the isotopes neutral. And it's trying to ask you, what is the difference between 2 strontium isotopes of each other? Now, remember, when you write your full atomic symbol, the mass is up in the front. So that means that this number tells me the mass of that strontium. So that one's going to be 84. And this strontium is going to be 88. Okay. Now, we get our periodic table. Strontium's over on the left-hand side. SR. How many protons in strontium? How many protons in strontium? You got it. 38. Now, if it is neutral, what also has to be 38? Protons are positive. What's negative? Electrons. Good. Then, if I want to figure out how many neutrons I have, remember, these two numbers need to add up to that bad boy. So I would do in my calculator, 85 minus 38 gives me 46. That is 1 isotope of strontium. Now it's going to tell you you have an exact same thing, but it's an isotope of it that has a mass of 88. All I want to know is that you know that what's different between those two things. Can you ever change the number of protons? No. If it is still neutral, did my electrons change? No. Okay? And that wouldn't matter anyways. You could add as many as you want and it would not change the mass. What is different between these two isotopes is the number of neutrons. So if I have 46 over there to give me 84, 38 plus what gives me 88? That is very good, 50. Okay, so before we get into the rest of today's activity, I very, very, very much want everybody in here and everybody at home, let's finish this worksheet. You can finish the back, finish the front. I have not posted the key because I would like to hold on to that, and I will give you the answers here in about 5 minutes, okay? Periodic table calculator, let's do it. Does anybody at home have any questions? All right, so I see a lot of people going, getting ready here. Let's get some answers. For the second one, you should have seen that it was nickel. The numbers that you added in were 58, 28, 26. Did everybody get that one correct? Check. The next one, phosphorus, 15, 31, 0. Because I'm plus 15 minus 15, that makes it 0. And then you're there. Now, the next one was nice and tricky. People were like, how am I supposed to know what this is? Well, if you have mass and you have number of neutrons, you simply subtract, and you know that there are 6 protons in that element because 6 plus 7 gives me 13. You look at 6, and then you look on your periodic table and you tell me that's carbon. Talk to me.
For nickel, would you not round up?
For, oh, thank you. That's a good one. Now, nickel on your periodic table says 59. However, you've been given number of protons, okay? So I have to add 30 plus 28, and that's one of the tricky ones you're going to see, okay? If you're given information, don't just pull it right off the periodic table. Great question. Great question. I shouldn't have glossed over that. I'm sorry. And then for electrons, if I'm plus 4 and I have plus 6, that means I need minus 2 to get me to plus 4. Aluminum, you look it up, it has 13 protons, okay? I want to be a plus 3, so that means I need only 10 negative electrons. 27 minus 13 gets me to 14. All right, let's take a look at the back. This is chlorine 35. This is chlorine 37. Chlorine has 17 protons, no matter how you slice it. If we're leaving these neutral, they also have 17 electrons. The only thing you have to do here is 17 and 35. The difference for this one is 18 neutrons. 17 and 37, this guy has 20 neutrons. Okay? Feeling good. So now, what we're going to finish doing today, go ahead back and find your packet here. Find your packet. We are going to finish the rest of this packet. Okay? So it has a couple different things on it. We did not finish the bottom half of the first one, so you might want to finish that. We did not finish the bottom half of page 2, so you can also finish that. Then you are into the counting portion, okay? You probably got somewhere around halfway through. Remember, to get this, you go into it's the only week we have, but the Tuesday folder. And that's the slideshow, so you're going to count a few more of those. Then you have to do the post-lab questions. Once you have all your information here, it's going to ask you which ones are isotopes. Remember, when you have isotopes, you have to have a pair. So, for instance, when you look at station number 11 and number 12, they're both going to be oxygen, but one's just going to be a little bit heavier because remember, isotopes are the same element, but with a different mass. Okay, you have to have two of them to compare. Then you're going to comb through and you're going to tell me which ones represent ions. Can anybody remind me what an ion is? An ion is a particle that is charged. Thank you. So anything that has a charge, either positive or negative. Okay, so you're going to write those. Then for number 4, you're going to pick the ones that are atoms. Ions are charged, but atoms are neutral. So anything that has a charge of 0, when you're writing your full atomic symbol, will fall into that category. So you're going to kind of break them down. Some of them might fit in multiple categories. Some of them might only fit into one. Okay. Then all that's left on the back piece of paper is I want to give you more of those practices if you would like. Okay. So I'm going to give you the next 20 minutes to finish this packet, do the parts that you need first. If you need the most practice on this idea, remember this one's going to say a difference between atoms and ions. The bottom half of it, though, is going to give you your isotope comparison practice. If you want to work on the chart because you had a hard time with the chart, keep counting up your electrons, protons, and neutrons. So we're finishing this packet today. Okay? I'm going to wander around out here. Then I'm going to come bother you people at home, make sure everybody's feeling good, and we should be off to the races. All right. So